Hello everyone, happy to see you here. Welcome back to my channel Hi Mathematics. Today we have a very interesting equation b squared minus b cubed equal to 2. We need to solve this equation for b, so if you have your answer, your solution, you can write your solution in the comments below and then we will check our answer. So it will be really interesting to exchange our information in the end of the video. So first of all, let's subtract 2 from both sides. This is our first step, so let's do it. So we have b squared, so the same beginning, b squared minus this b cubed, b cubed, and we have minus 2. Okay, we subtract 2 from both sides, minus 2 and equal to 0. Right now the second step, so I suggest you to express these two as 1 plus 1. Okay, so let's do it. So we have 2 equal to 1 plus 1, and a lot of students may be asking why we choose this option, why 1 plus 1, why not like 2 plus 0, why not like 3 minus 1. So in the end, in a few seconds, I will explain you why 2 equal to 1 plus 1 is the best way how can we express it. So first of all, let's do it. So we have b squared minus b cubed, and instead of this 2, as I said before, we're going to write this 1 plus 1. Yeah, so we have 1 plus 1 equal to 0. Right now let's open our parentheses real quick. So let's do it. So we have b squared minus b cubed minus 1. Yeah, we don't need this parenthesis, minus 1, and of course we need to change this sign to the opposite one because we have a negative. So we have minus 1 equal to 0. And right now let's look closely what do we have. So we have 4 expressions. So we have 2 variables and 2 constants. This one b squared, this one b cubed. But how can we express this constant? Maybe we can express it as 1 square and 1 cube, and then we can group squares and cubes. And that's why this way is the best for us, because this one, for example, this right here, we can express as, for example, 1 square. But this one we can express, for example, as 1 cube. This is up to you. 1 cube, 1 square, doesn't matter, yeah? So we have 1 cube. Okay, so let's do it right now. This one we can express as 1 square. This one we can express as 1 cube. So let's do it right now. So we have b squared minus b cubed minus 1 square and minus 1 cube. Okay, equal to 0. And right now this is, I hope you see why we can express this 2 by 1 plus 1, and this expression is the best for us because we can express this one as 1 square and this one as 1 cube, so we can group it. So we we have b square and we have 1 square, and we have right here b cube we can express as 1 cube. So let's group our squares and let's group our cubes. Let's do it right now. First of all, our squares, b square minus 1 square. So b squared minus 1 square in parentheses, of course. And we have the second expression. So we have minus our cubes, b cubed, but plus 1 cube, because we write it in parentheses. So we have b cubed plus 1 cube equal to 0. Okay, so I really hope you understand this part. Right now let's look closely. What do we have? We have difference of 2 squares and we have a sum of 2 cubes. We really need to know about 2 formulas, very basic, very great, like school formulas. First of all, right here, difference of 2 squares. So we have x squared minus y squared. According to your school knowledge, you can easily, you should know this. Maybe this is like the most popular formula. We have x plus y, for example, x plus y. And we have x minus y, so we multiply it. And of course, we really need to know about a sum of 2 cubes. Let's do it right now. So a sum of 2 cubes, so we have x cubed plus y cubed. Let's learn this formula. And right here we have x plus y, and we have the second parenthesis, x squared minus xy, and plus y squared. Okay, so I really hope you understand it, y squared right here, yeah? Right now, let's apply this formula. Right here, difference of squares, right here, sum of 2 cubes. Let's do it right now. I'm going to start it on the left side right here because it will be like a long line. First of all, difference of squares. So we have b minus 1, b plus 1, or doesn't matter, b plus 1, b minus 1, this is up to you. I'm going to start with the b plus 1. Let's do it like that. So we have b plus 1. b minus 1, yeah, b minus 1. We have minus, and we have a sum of 2 cubes. So we really need to know really need to know this formula, and let's apply it. So first of all, we have b plus 1, yeah. So we have b plus 1, and we have the second parenthesis. The second parenthesis we have b squared minus b and plus 1. equal to 0. Okay, so we applied this formula. Really great. The second step, if you look closely, we have like two sides. We have this subtraction sign and we have two sides. The first one we have a product, and on the second side we have also a product, but we have a common thing. We have b plus 1 on the left side of this subtraction sign and b plus 1 on the right side of this subtraction sign. So we can easily factor this b plus 1. Okay, let's do it. So b plus 1, we factor it, so b plus 1, and in another parenthesis, what do we have? I'm going to write this parenthesis. We still have this b minus 1, yeah? B minus 1, and we have minus, of course, we really need this expression, because we factor b plus 1. From here, from this side, we have only b squared minus b plus 1, so let's do it. So minus b squared minus b and plus 1 equal to 0. Right now, let's simplify it. So we factor it, everything is great. We can easily simplify this expression in the second parenthesis. Okay, so let's do it. So we have b plus 1. In another parenthesis, what do we have? We have b minus 1. Yeah, I'm going to open a parenthesis real quick. B minus 1 minus, from here we have b squared plus b and minus 1 equal to 0. Right now, let's simplify it real quick. We can easily change in order. We can easily find a common thing. We have b right here. We have a constant. We have constant right here. So right now, let's group everything and let's write our final expression. So first of all, the same beginning. So we have b plus 1. And in another parenthesis, we start with minus b squared because it looks like a quadratic equation. Here we have the second power. This is like the highest power, so it means that we group it in terms of like quadratic equation. Ax squared plus bx plus c. So let's start with b squared. So minus b squared. What do we have right here? B and b. We have plus 2b, and minus 1 equal to minus 2. So we have minus 2 and equal to 0. Really great. Right now, a product equal to 0 when the first parenthesis equal to 0 or the second parenthesis equal to 0, okay? So let's start, for example, with this side, so with this left side of this multiplication sign, yeah? So b plus 1 equal to 0, this is basic equation, so b equal to minus 1. This is our first, so I'm gonna underline that this is like b first, and right now the second part. So we have quadratic equation, so minus b squared plus 2b and minus 2 equal to 0. But you know, a lot of students may be asking why do we have this negative right here, because a lot of students prefer solving this quadratic equation without this negative sign in the beginning, and I understand why they prefer a classic version without a negative sign. So that's why we really need to multiply or divide both sides by minus 1. It changes nothing on the right side, but we need to change all the signs to the opposite one. So let's do it. So we have b squared minus 2b and plus 2 equal to 0. This is our quadratic equation, and right now let's solve it. This is up to you. I'm gonna solve it with the basic method of coefficients. So first of all, we have a equal to 1, b equal to minus 2, and c equal to 2. Right now, let's find discriminant. Yeah, this is our basic method. B squared minus 4ac. This is our discriminant. Let's plug in each of these elements into this spot. So we have b squared, so minus 2 squared, minus 4ac minus 4 times a times 1 times c times 2, and as a result we have minus 2 squared equal to 4 minus 4 times 2 equal to 8. So our discriminant equal to minus 4, so it means that in this branch we're gonna have like two complex root. It means that because we have less than 0, so a lot of students might be thinking we don't have real number root. Yeah, this is correct, but we have two complex root. So it means that complex root right here, real number root right here. But let's solve it. Let's find our complex root. So that's why we're gonna write it as b second and b third. So b second and third equal to, we have minus b plus minus square root of discriminant and all over 2a. This is our classic formula. So we have minus b minus 2 plus minus square root of discriminant square root of minus 4, and we're gonna divide it by 2a, 2 times 1. Minus minus equal to plus if we're talking about multiplication, so we have only 2 plus minus square root of minus 4. A lot of students might be thinking maybe this is equal to 2, we have 4, square root of 4 equal to 2, but we have minus 4. So this is like a little bit different thing. So I suggest you to split it like square root of minus 1 times square root of 4. Yeah, and right now, of course, we have right here our 2, but square root of minus 1 equal to our imaginary unit equal to I. So we have 2 plus minus 2i in our numerator over 2. And one really important trick, a lot of students like don't know this trick. I'm going to show you this. We can easily divide by parts. We can easily divide this numerator by these two, so by parts. This element by 2 and this by 2, so we can split it like 2 over 2 plus minus 2i over 2. Okay, and as a result we have 1 plus minus, right here we're going to cancel it, and we have 1 plus minus I. These are our two complex roots. So let's write our final answer, but before writing final answer, I'm going to check real quick our b first equal to minus 1. So let's do it. So check, yeah. So we have b square minus b cube equal to 2. Okay, let's check this minus 1. So we have minus 1 square minus 1 cube equal to 2. And let's do it. So minus 1 square equal to 1, minus 1 cube equal to minus 1, because we have an odd power. So it means that we keep this one multiplying by this one. We have plus 1 cube equal to 1. And yeah, we have a great answer, a correct root for us. So let's write our final answer to this question. So our answer, so b first equal to minus 1. This is our real number root, yeah. b second equal to 1 plus I, and b third equal to 1 minus I. These are our two complex root. This one is a real number root. And this is a solution to this question, 3 roots, and according to a fundamental theorem of algebra, a lot of students might be thinking why we are like sure that we have only 3 roots. According to a fundamental theorem of algebra, when we have b cube as the highest power of our equation, that doesn't matter, we can easily find out that the highest power is b to the power 5, for example, b to the power 6, and it means that we have fixed roots in total. We don't know how many real number roots, how many complex roots, but we have a fixed root in total. This is our example, but in our case we have b cube, yeah? So it means that we have 3 roots in total. We don't know how many real number roots, and this is like the maximum amount of roots, yeah? We can't have right here in this part, we can't have like 4 roots. We have only 3 roots. We can have only 1 root, we can have only 2 roots, we can have 3 roots, but we can't get 4 roots from here because according to a fundamental theorem of algebra, third power maximum, it means 3 roots in total. In our case, 1 real, 2 complex. It can be like 2 real, 1 complex. So, a lot of combination, but in our case, everything is great. Third power is the highest one, so it means 3 roots in total. So I really hope you understand my solution. You can easily pause the video and try to understand it once more, but in our case, this is a great solution, I guess, because the second way how can we solve it is to use like Cardano formulas. I don't like this formula a lot, to be honest, because this is like a long and complicated stuff with the roots. I don't like it. And according to this method, you can easily find like combination. You can easily group squares and cubes. But it's not like a common, it's not like a basic method, because, for example, imagine we have right here, for example, 5. So how can we work with it? Because we have 5. So how can we express it? How can we group with squares and cubes without any problems? Yeah. Okay. So I really hope you understand my thoughts about it. And this is my solution to this question. So I really hope you understand it. So thank you for your time. Also write your thoughts, write your response in the comments below. Let's discuss a little bit about this type of question. It's also really interesting, and it's really great to see your response, to see it from your perspective, because a lot of countries, a lot of approaches. What do you think about it? Also write your response. I will be really grateful if you leave your response in the comments below. It also improves our community, and of course a lot of thoughts, a lot of discussions, mistakes, of course, yeah, because maybe a lot of students are here and they do some mistakes, and it's also really great to discuss a little bit about this thing. Yeah, so I really hope you understand my way. I really hope you understand my approach. So thank you for your time. Take care of yourself. Have a great day. See you in the next videos.